Now for the scan grid, you stop your measurements, you stop your generator, and you can draw different geometries depending on the type of measurement you want. So for instance, we have 1, 2, 3, 4, 5, 6 circular membranes here, and we want to know how they deform in reality. So you need to click this button that says define scan points, and it'll zoom in on your video image, and now you have different shapes that you can choose from, and each shape will be filled out with scan points. So I'm gonna use a circular, I think it's a create ellipse. So I'm gonna just draw a circle that covers my membrane, and you can see different options to fill it out. So you can have points inside, or inside on the edges, or just on the inside, or just on around side on the perimeter of your circle shape. And you can actually have different distributions, a square grid, some sort of like spider web, or hexagonal, or like an irregular grid. I normally use this one because it gives you like an acceptable results. And the density. So the density is the number of points you can have in that. Increase the number, you'll increase the number of points. The trade-off, it'll take longer, but you'll get a much better measurement. So let's use, I think, 30. Let's use 40. No, let's use 30 for now. Okay, so that's your first membrane. Now you can just click Control copy and move it to different membranes. You can select multiple of them, and then you can create this kind of grid. Once you're satisfied with that, click again this define scan points, and they'll be shown in the screen. So now what the system will do is it will automatically raster the laser over each of those scanning points, and it'll take a measurement of it and it'll record it, and it'll do it until it's done. It'll post-process it, and then you can see the measurement variation. So I'm gonna hit this button. Now it's enabled because I defined my scan grid. So this one over here, like scan F9, I'll hit it, and it says you have assigned a valid focus value. Do you want to use assigned focus value? Yes. Now it'll ask you where you want to store this measurement. So I'm gonna store it in my folder, PSV demo. You can save it whatever you want, and it's gonna be saved as file name .svd, scanning vibrometer displacement. Save. And now the process is running. So you see different colors for the scanning. It's automatically, you don't have to do anything. So the green points are valid, the kind of gray ones are optimal. So the colors are here. And once it's done, it'll tell you this message that the scan is completed, and you have it took 16 seconds. Now, if for any reason you are getting invalidated or overrange measurement points, the system will automatically return to those points and try to scan them once again. If the system still reads an overrange, they'll just invalidate those points. A way around it is, and that's probably because you are not having sufficient bandwidth in your channel. So remember to start with something small, from 0 to 200 millivolts, and then for 500 millivolts, 1, 5, and then 10 volts. So increasing in range. And another way around it is to use a lower voltage for your signals. In our case, like the majority of the points were optimal and the rest were valid. So I'll just click OK, and now my file has been saved.
You can also deactivate
Yeah, so you can actually go, where's the button here?
Presentation.
Yeah, so if you click this button, you'll open up another software which is PSV presentation, and it will load the latest scanner. So I'll click this button, and then it's gonna open the PSV software. And PSV software, point scanning vibrometer software. Yeah. And it loaded a design that
yeah, the last users.
Yeah, so that's this chunk.
Yeah,
that's your design.
Hello.
Yeah. So I'm gonna load our design now, so you can close this guy.
Ah, that's also mine.
That's yours. That's yours.
No, that's not mine.
Okay.
Yeah.
Okay.
So that's why he was banned.
Okay.
Okay.
So now I'm gonna open. So if you don't find it, you can either go to the Explorer, or you can actually directly open it out from here. So PSB, and then what's the name? 2019 0816A. So I'll open it. So that's our scan. That's how it looks like. And you might see, you know what? That's just some green dots. Yeah. In reality, it's not. So if you want to capture the or you want to see the frequency response of this one, is you click here and change view, and click on average
First
spectrum.
The point data.
Oh yeah, point data, very important. So point data, and then average spectrum, and it'll show up down here. Yeah, hit auto scale, and that's the like the frequency response of these devices. Now, if you want to get a 3D view of how it looks like, you can rotate it like that. You can zoom in and out, and very neatly you can animate it. So you click this button, you can see.
I think you also should move the cursor to the frequency value.
Oh yeah.
So that it gives you So that's my.
So if you want to have a faster animation, just click this plus button, and it'll run faster. If you want to increase the scale, you can just scale up or scale down. That's the real deflection of the membranes. That's what happened.
Run from left to right.
Pardon me?
The color engine. So.
Or is it really like? Because first it's the left one that activated, then the middle, and then the right. Is that because of the?
This one over here.
Yeah.
If you play it slower, like then first the left one starts to vibrate, then the middle two start to vibrate.
Yeah.
It's a phase delay.
Because of the.
The
contacts.
Yeah, there are many factors can affect that. So remember, so if I select a different frequency, that's how they vibrate. If I move to the peak, they should vibrate all at the same time. Nevertheless, in microfabrication, you sometimes obtain different variations. So maybe that slight delay is because this sample is really old. It's like 6 years old, and it has been sitting on the shelf. Maybe it has some dust on it. That's probably some reason why you have that. And what else can you do? Okay, so this is to detect the resonant frequency of those membranes. So I've done a few more measurements on a different kind of CMOT. So let me open that up just to
actually,
see.
there were also two things which I think should be mentioned.
The,
so in general, because you guys are all dealing with a massive array of transducer, so maybe just like here, you measured 6 of them, but you want to extract the resonant of each single one. And to do that, it's relatively easy. So first you cancel the movement. In the edit, select all the points. So basically in this wheel, it shows you all the points here. And then in the view, in the edit, modify selected point, you invalidate all of them so that all the measurement will not be presented. And then if you want to, like, for example, just extract the measurement of one of them, the same thing, like select a point, or like as far as I remember, if you click, you move to the cursor, and it would allow you to draw. Yeah, so you click Shift. Meanwhile, it will allow you to draw them, and here you in the modify the selected point, you only validate them, and there we go. So now what you are seeing, what you are looking at, is only the measurement of the single membrane. This is critical in the way that you have a membrane you want to extract. Particularly for this kind of circular plates, you want to extract the quality factor sometimes. You don't want to have all the measurement presented here because it gives you the average spectrum, and for sure the edges here has a lower displacement magnitude, which in return gives you it's basically drag down the resonant frequencies. So you may want just to select the center area. So this is critical, particularly in the way that you scanned like 100 of samples and you want to extract each of them.
Yeah. Thank you, Chang. Another option is going back to your measurements, and instead of having this 6 circular array, you have points here. 1 point here, 1 point here, 1 point here. Or just draw a rectangle to have 6 measurement points. This is an enlarged like a zoom inversion. But if you have, let's say, a view of 100 cells, you can have just 100 points, and then you can measure the vibration of each one. Yeah.
This is basically a trick for large area.
Yeah, large area transistors.
measurements.
Yeah, and I'm gonna show you one of the demos I.
Oh, by the way, extraction of animations.
Oh yeah, well yeah, that's important as well. So I'm
I
gonna.
think it's validate all. So
Yeah, file. No, it's.
edit, select all, validate
yeah.
all. Yeah.
Mm-hmm.
And validate all.
Validate. There you go.
And I think average spectrum. I think.
Mm-hmm. Point. Average spectrum. Where
Maybe.
is it?
No. Yeah, why the plane is still gray?
Mm,